Alright everybody, welcome to the video on graphing quadratic functions in vertex form. You probably have in front of you a paper that looks similar to this, and what it's asking you to do in these first directions is to write the vertex of each of the following polynomials in vertex form. So when I discuss vertex form, so far this chapter we have been dealing with standard form, which is f of x equals ax squared plus bx plus c. In this particular form, we're able to plug in numbers using the remainder theorem and graph equations. Although it is time consuming, it is a for sure way of making sure that you graph the correct function. However, in this case, when we bring up a different type or another look of a quadratic function in something called vertex form, which is, we're kind of diving into this stuff right now. Now, the nice thing about vertex form is it allows us to very quickly develop a graph of a quadratic function. Now, in later parts of this unit, we will be learning how to transfer something from standard form to vertex form and vice versa. But for right now, we're just going to get the basics and the general idea for the vertex form. Now, this particular method of graphing quadratic functions and its transformations holds true for a lot of functions in math. The square root function, absolute value function, sine function, cosine, trig functions. All of those particular functions have this basic idea of transformations. And this is our first step into that with the vertex form. So you notice that I've broken down this function, or the quadratic function, and this is kind of how the vertex form looks. It looks a little different than our general standard form, but yet you'll see how it is an advantage, especially when we are graphing functions. And so our first thing to discuss is that what goes on inside the parentheses, that's going to cause some horizontal movement, or that's going to cause the vertex to move. The k is going to cause the vertex to move up or down, okay? So these particular numbers right here, or this part of the vertex notation, only affects the vertex, okay? So when we discuss in this case, the h and the k, that's going to affect the location of the vertex. The number that appears in front of the parentheses is going to affect the amplitude, or this is going to change the way the graph looks, either through a stretch, or it might flip over, it might go down, up, but for the most part, or for the time being, this A is going to really affect the look of the overall graph. It's going to change how wide it is, how maybe thin it is, or narrow it is, depending on its stretch. Okay, so the first thing we need to do is really bear down on this vertex form. So if you have this paper in front of you, you will see that it's asking you to write the vertex. Now I've copied some of these down. Now number 3 is actually number 5 on your paper, and this number 4 is number 6. I'd also like to point out that on the back side of this paper it has some more just kind of graph and equations, and this first one right here, this number 5 in my particular problem is the number 4 on your other paper. Okay, I just wanted to make sure that you can follow along as I work these problems. So let's first start out by discussing what this vertex form does. Okay, now we can sit here and we can plug in numbers to prove our answers, but for right now we're in the era of just really kind of breaking down and really graphing these things with the vertex form. So first thing we're going to do is we're going to write down the vertex. So you'll notice that I discuss horizontal movement. Okay, so the vertex is going to be h comma k. Okay, so the number that's in here and k. Now we need to make sure that we can almost put an opposite of k, opposite of h in this case. So for example, our vertex for this particular quadratic equation is going to be 2. Here, I'll write this in a different, I'll use blue. So the vertex for this particular function is going to be 2, 4. So it's the opposite of what's inside here. So see how it's negative 2? It's going to change to positive 2. And with graphing and more experience, you'll understand why that is. And we've done some experience to figure that out as well. So if you take a guess at number 2, take a moment here, you'll notice that the x-coordinate of the vertex is negative 1 of what's inside, and then the vertical movement is going to be negative 2. So let's get to graphing on this, since I've left some graphs below on your paper to kind of start graphing this. Our vertex here is going to be at 2, 4, so we are going to graph 2 and 4. So that is where that particular vertex exists. Okay, again, I had that movement from my vertex. This particular one exists at, number 2 is -1, -2. So that is where the vertex exists for number 2. Let's now look at number 3 here. And although there is a negative sign in front, that is only going to affect the change or look of the graph. We're still going to go through our same procedures. In this case, we have a vertex of 1, 5. So that is 1 over 1 up 5, 1, 2, 3, 4, 5. All right. So you can see how that nothing up front is not changing anything. It is only this stuff, the stuff inside the parentheses or inside this kind of squared function or quantity is going to be the horizontal movement, and the guy at the end is going to be the vertical movement. Similar to when we graph linear equations, this is going to affect vertical movement, similar to what it did on the y-intercept of a linear equation. So you can kind of see, or you can see connections between functions as we move along. Now this particular one, number 4, in my video here, it's kind of got something weird because it doesn't have the parentheses squared, it just has x. But if I rewrite this in terms that maybe put it in vertex form, we have -2 x plus 0 squared plus 5. You can see that although we don't have the parentheses with the squared, it is x plus 0. So our vertex for this particular equation is going to be 0. It has no horizontal movement, and it goes up 5. So I will graph that 0, 1, 2, 3, 4, 5. Okay. If you look at the back side now, you can kind of graph these as well. This particular vertex is at -3, 3. And I kind of throw another sideball at you in that there is no vertical movement, and so this particular function is just going to be over -1. Okay, I almost made the mistake there. Trust me, you will make the mistake once in a while. We see the +1, so we want to go over 1. Make sure that what happens inside the quantity is going to be the opposite. So opposite of h, so this one would be -1, 0 would be the vertex of this equation. Alright, so we've graphed all the vertices. That's a great thing because now we're just going to break down some pattern work. Okay, so yesterday and the previous day we've kind of looked at the pattern that develops in the vertex, and I've kind of written that pattern right down here. The common pattern that you see here is just a basic one. If there is nothing in front of this, meaning that there is 1 in front of the parentheses, the basic combination of numbers are these odd numbers, 1, 3, 5, 7, 9, 11. And so what that means is we're always going to go out 1, always out 1, and then this tells us our first movement. So in this case, I'll go out 1, up 1. And I know with parabolas, because we've talked a lot about it, is that with the axis of symmetry coming right down the center of the vertex, we also have another dot, or the same dot, on that side. So we have up 1 over 1 in both directions. Now this particular, the next one, so that was up 1 over 1. This one is up 3 over 1. So I'm going to go 1, 2. Here, I'm going to take those check marks off there. I'm going to go up 3, 1, 2, 3 over 1. Now, I've chosen some bad numbers to make this graph useful, but I'll show you on the next one here. So up 3 over 1. And then you'll notice that if I had some room, which I'll show on this one, I would then go up 5 over 1. So let's try that out. So because there is no number in front, I'm going to go up 1 over 1. I'm going to follow the simple pattern here. Up 1 over 1. I'm then going to go up 3 over 1. Up 3 over 1. And then my next one is up 5 over 1. 1, 2, 3, 4, 5 over 1. And so on. Now you'll notice that this is kind of like graphing a linear equation in that instead of the slope may change a little bit because of the pattern or the number that is in front. Similar, I keep making reference to the idea of linear equations, is that if we have a linear equation that looks like this, you're just going to go up 1 over 1, up 1 over 1, up 1 over 1. Okay, if I put a 2 in front, you go up 2 over 1, up 2 over 1. And so you can see how here in a second how this is going to affect that. So let's bring that into play right now. So instead of being 1 in front, I now have a -1. So how that pattern is going to change everything is I'm going to take everything times -1. Let me put a negative sign here. Let me use red here to symbolize negative. So I'm going to take this times -1, times -1, times -1. I'm going to take my whole entire pattern that I would normally hold for just an amplitude of 1, and I'm going to take them all times -1 to show the new pattern. And so in this case, instead of being just 1, it is -1, -3, -5. And so how that pattern is going to look is instead of going up 1, I'm going to go down 1 over 1. We always go over 1, down 3 over 1, and then down 5 over 1. 1, 2, 3, 4, 5 over 1. So you can see that the pattern holds true. And I recommend, if you are unsure about your graph and maybe you are completely lost, we can make sure that it is correct by just plugging in a number. We can always plug in numbers into functions to make sure things are correct. On this final one, you'll see, I'll show again how this pattern thing works, is that if we try this, we've already graphed the vertex, we've graphed that, that's all good to go. And now if we have you notice that the number in front is -2. So I'm going to take all these times -2 to show my new pattern from the vertex. So I'm going to go down 2, down 6, down 10. I'm probably not going to get into down 14. But so my first motion, instead of being up 1, it's down 2 over 1. Down 6 over 1. 1, 2, 3, 4, 5, 6 over 1. And I can go a little bit further too. Now we'll talk more about the effects of this amplitude in class together. But it's very important that we notice that you'll see the change that has occurred here. It's a little, in the original, the -1, it's a little bit wider. When we start putting numbers in front, whole numbers, it tends to it stretches down. Okay, so, or it stretches, it makes it thinner or more narrow of a parabola. But we'll do a lot of experiments with those here in the near future. All right, so take a moment and see if you can graph this particular function. It's on the back page on number 4. So press pause real quick and then we will check this answer to make sure you are correct. All right, welcome back, and hopefully you got some time to look at it, discuss it in class. You'll notice that we have already graphed the vertex, of course, and you know that the amplitude in front is -2. So what that's going to do is it's going to cause me to multiply all my regular patterns times -2. And so again, that makes the same exact pattern, -2, -6, -10, so on and so forth. And so from my vertex, I'm going to go down 2 over 1, down 2 over 1. I'm going to go down 6 over 1. 1, 2, 3, 4, 5, 6 over 1. Now, this is an important combination here is because you notice that it's the exact same parabola here, but the only thing that has changed is that I have changed where the vertex is. It still looks the same, but because of this transformations, horizontal and vertical movement, it has moved around the graph. Okay, so that's a very important thing. My last one, I should have probably chose a different one here to kind of show you a bigger effect. But if I have, let's just try it out. Let me change this to -3. This is my own problem. So let's change that to -3. And let's say, for example, and you can kind of predict what's going to happen. Or let's say we've done too many negatives. We need to get positive here. So let's do a +3 out in front. The amplitude is going to be +3. I've already graphed my vertex. And so you can imagine what's going to happen here is we're going to put times 3, times 3, times 3, times 3. And because this amplitude is so high, we're not going to be able to do a lot of the numbering because on one of these I'm going to have to go up 15 over 1. So from this I'm going to go up 3 over 1. And then I have to go up 9, which I don't have enough room in my graph to do. So I'm just going to have to kind of guesstimate. But you'll notice that this particular parabola has really narrowed as I increase the number up front. I'm hoping you guys also notice that the negative sign up front is going to flip this thing. So for example, here I was all positive. Here up here I was all positive because I had positive amplitudes. And then when I put a negative sign, we noticed that it flipped and we started going down. So there's a lot of patterns that we're still looking at and a lot of things that we're still learning, but I hope this video helped you out. I've provided you a lot of problems to try out, to check, and so the more practice you can get with this, the better you get at it. Thank you for your time, and I'll see you next week.